In this video, I'm going to demonstrate how you can first create a question bank and then create a new question and put it in the question bank. And the question that we're going to be creating is one under the WIRIS category, where you can design mathematical types of question, and we're going to look at a specific type of question which is the cloze, C-L-O-Z-E, embedded type of question. So in order for you to start, first you go to the course page in ULearn, and then you scroll down and find question bank under administration. So click on question bank, and then we will first create a new category for our set of questions. So let's click on categories. So now I'm going to add a new category, and here I'm going to put this at the top, meaning that it is under the main section of the course. So in this case, the course is called Associate Professor Dr. Nasrin Badruddin, but it can be whatever course you're using. So I'm going to choose the parent category as top, and then I'm going to name the category. So let's say I'm going to create questions related to circuits. And then that's it. You can put a description if you want. This question bank is related to circuits, for example, and then you just add category. So now you'll find that we have a new category for our question bank, and currently there are no questions in this category. Okay, so before we proceed with creating the new question, let me just introduce the type of question that I want to design here. So I'm going to give the students an image of a parallel circuit with three resistors in parallel and a voltage source. So I would like the students to calculate the current that goes into each of these resistors, and also the equivalent resistance for these three resistors in parallel. So if you have an image, a circuit like this, then it will only give you fixed values for the resistors as well as the voltage source. But if we want to make it a bit more difficult for the students to copy from each other, we can actually randomize the different parameters for our circuit. So for something like this, it's more appropriate to use a picture where the values or the parameters are not included in the image itself. So instead of using this kind of image, I'm going to use this image, which is a more general image where the values of the resistors are not given, as well as the voltage source. Now going back to ULearn, we can create, there are two ways you can create a new question within a new category of question bank. One is to go back to the category and click the number next to that particular category. So that's one way of doing it. Another way is if you just go to question and you choose questions, you can also create a new question from here. So make sure you choose the right category. So in this case, I'm going to create a new question under circuits, and I'll just press the button, create a new question. Okay. So because the way I want my quiz question to be, I'm going to ask the students to calculate 4 different values. So instead of creating one question for each of the value, I'm going to use an embedded type of question. So if you go under questions, actually, you can find the embedded answers or closed types of question, which allows you to have more than one text field or multiple drop-down box and so on, meaning that the students can answer multiple questions or chain questions, sub-questions within one quiz question. But I'm going to not only make it an embedded answer, I'm going to make it an embedded answer type of question, which also uses WIRIS features. So under WIRIS quizzes, I'm going to choose close and science. Okay, in WIRIS science questions means that the questions are usually mathematical types of question, and they are embedded type of and it's also an embedded type of question. So just add that question. Okay, so I'm going to call this question parallel circuit because it's a question on a parallel circuit, and because the question needs to refer to a circuit, so I'm going to add the image of that circuit that I have, the general image. So you need to click on browse repositories, and because I haven't put this image file into my ulearn yet, I need to upload the file. So I will choose my file, and in this case it's going to be, where is it? It's going to be located here. Okay, so upload the file and check that is the right circuit diagram. You need to put a description. If you don't put a description, you can't save the image. Usually I just put description is not necessary, and then I just save image. Okay, so now the image of the circuit appears at the beginning of my question. Now I'm going to type the actual question. So the circuit shown in the figure above has the following parameters. And what I'm going to do is I'm going to randomize the value for Vs, R1, R2, and R3. So in that case, I need to do two things. Okay, the first one is I'm going to use the equation editor, so that my symbol Vs looks nicer. So this is a tag-based type of equation editor. So if you know how to use tag and LaTeX, then you will have no problems with this. Otherwise, you can just use any of the buttons here to design your equation. So in this case, I want to write V subscript S, which is like this, which appears like this in which is written like this in tag, and you can see the preview here, and then I save my equation. So this one is not an actual equation, it's just a formatting of the equation to be displayed. Okay, and I'm going to say that the value is equal to a variable. So in WIRIS, if you want to define a variable, you need to use the hash sign. So when you use a hash sign, it means that it is going to be a variable, and the quiz will look at the algorithm to determine how to create the values for this variable. So I'm going to call this variable Vs, the same name as the actual variable that I use. Okay, then I'm going to do the same thing for R1, R2, R3. So I'm just going to copy paste and just changing it here. So this is R1, and the variable name is also called R1, and we have R2 and R3. Okay. Okay. So now that I've created the parameters that I want to randomize, the next thing is to create the embedded answers for the students to answer the question. So let's put it the following values. Okay, And I'm going to ask them to determine first I1, right? So I1 is equal to, and then I'm going to put the embedded answer here. So for you to create an embedded answer, first you need to use, open a curly bracket, okay, and then you put the point value, how much this question is worth. So I'm going to say it's worth 1 point, okay, and then you put the colon, and then actually you put 2 colons, and between the colons you're going to define what is the type of answer that the student is going to enter. Okay, it can be multiple choice, it can be a drop down box, or it can be a short answer. So I'm just going to use short answer. So write short answer. Okay, what happens is when you choose short answer, it will create a text field for the students to manually type in the answer. You can use short answer, you can also use SA. SA also stands for short answer. And then after that, you put equal, okay, and that will, the equal sign, whatever comes after the equal sign is the correct answer. Okay, so in this case, my correct answer, because I1 depends on whatever random variable is generated by WIRIS. So I'm going to make it equal to another variable, and I'm going to call it I1. I1. Okay, and then close curly bracket. So that's your first embedded answer for the students to put the value of I1. Okay, so let's just pause there and see how the question looks like. So you click on Save Changes and continue editing. And then to preview, you just click Preview. And this is how the question will look like. So because we haven't created the algorithm to randomize VS, R1, R2, R3, it's just going to show the variable name right now. Now, this is what I mean by the embedded answer. So you will have the answer field within the question itself. So in this case, I've already created one embedded answer for I1, and it is a short answer. Okay, so this is how it would look like. We can do the same thing for the other three current values. So I'm just going to copy paste and just change this. This is going to be I2, and then this is I2, and it's also worth 1 point. And I'll do the same thing for I3. This is also worth 1 point. And then I'll have another one called the total resistance. So let's say I call it total resistance, or the equivalent resistance, and I'll say it's R total. So I'm going to copy this. Again, this is just a tag script so that it comes out nicely as an equation, and that is going to be equal to my embedded answer. Oh, sorry. Okay, and this time it's going to be worth 2 points because there's a bit of the students need to do a bit of calculation there, so I'm giving them more points if they get this correct. And the variable name, I'm going to call it R tot or R total. Alright, so let's just save and let's preview. So you will see now we have 4 different fields. Okay, I need to fix this for I1, I2, I3 as well as R tot, but I need to fix the tag for this. It should be actually the entire thing is a subscript. So save that and preview again. Right, so now 4 different values that the students need to determine and enter in order for them to answer this quiz. Okay, so I've set up my question. I've designed how the question looks like. The next thing is I need to write the algorithm so that when the students attempt this quiz and submit it, it will be automatically graded, so I don't have to manually grade it. And to do that, I will click at under WIRIS variables, I will click this button next to algorithm. When you click the algorithm button, a new window will come up, which is the WIRIS Quizzes Studio, and we will go to the variables tab and click on the button edit algorithm. So when you do that, what happens is it will ask you to download this Java file. So you just download it anywhere. So you save it, and then once it's saved, it appears down here if you're using a Google Chrome. Then you just need to open it. And when you open it, it will open up Java. Oh, by the way, for you to do this, you need to install Java first. So if you have an error saying that it doesn't know how to open the file, then you need to install Java first. So I will run this. Okay, and you have to wait for the algorithm window to come up. Okay, so this is the editor for your algorithm. So under my variables window here, I am going to define the values for my VS as well as the recurrence. So let's start off with defining VS. So VS is going to be equal to, and I'm going to use the function called random. Okay. The random function creates integers between 2 values. So let's say if you put within the round brackets 1 to 6, then it will create it will randomize between the values 1, 2, 3, 4, 5, 6. Okay. Another way you can do it, which is what I'm going to do here, is I'm going to let it take a random value from a set of values. So I'm going to put it, let's say 3, 5, 6, 9, and 12. So 5 different sets of 5 different values in the set of value for VS. And then I'm going to do for R1, because that's the other thing I want to randomize. So also use random. Now, if in this case I'm going to create resistors in the thousands, and it's going to be between 1,000 to 9,000. So one way you can do it is you create a random number between 1 to 9. It's going to be integers, and then you multiply. So you use the asterisk sign, even though you use asterisk to mean multiply, but it will come up as a dot in the variables window. Okay, and I'm going to multiply it by 1,000, meaning that it will generate resistor values between 1,000 to 9,000 in increments of 1,000. Let's do something else. See, in this case, I want to randomize between 2 to 8, and then I want to multiply it by, let's say, 100. And finally, we have resistor values between, let's say, 120 to, I don't know, 500, for example. Okay, so in the first example for R1, it will only create resistor values of like 1000, 2000, 3000, all the way to 9000 in increments of 1000. For R2, the resistor values will start from 200, 300, all the way to 800 with increments of 100. In the case of R3, it can be any random value between 120 to 500 in increments of 1. So you can have a resistor value of 127, for example. Now, remember that the values of the four values that the students need to answer is also a variable. I mean, they are all variables. So, for example, I1 is going to be dependent on the value of Vs as well as R1. So because we don't know what the value is, that's why we said that the correct answer will be equal to the variable called I1. So now I'm going to write the equation which defines the variables that will be used to check the answer for given by the student. So I1 is going to be equal to Vs divided by R1. Okay, so let's just stop there for a while. I'll leave it there for a while because I want to demonstrate to you what happens when we click this equal sign. Now, this equal sign is used for you to simulate the possible values that will be generated by this algorithm. So when you click that calculate sign, the equal sign, you will have another at the bottom where you are able to simulate the values. So let's say I want to see one simulation. I want to see what's the value of Vs, and then R1, sorry, big R1, R, just R2, okay, R2, R3, okay. Now make sure when you click the values, they are all within the same, enclosed within this bracket, this square bracket here. Because if you type below this, if you create a new square bracket here, actually this constitutes another simulation, another set of simulations. So you don't want that. You want all of this to be part of the same simulation. So when you've done that and you click calculate, so it will show you the possible values that will be generated by this algorithm. Okay. Now these are the random parameters based on the random function that you defined up here. But we want to see what is the value of I1, which is based on the random variables that the random values that we generated. So let's also put I1, and then we click the equal sign. Okay. And now it simulates a new set of values. Now because I1 is Vs over R1, and that means that it's 6 over 9,000, then you will get this as the answer, which is 1 over 1,500. And as you can see, it's the correct answer. Now the problem with this is when you use the division sign here, you will get your final answer to be in fractions. And I've checked by putting in test answers when I set this up. If the student puts the number in terms of with decimal points, then the algorithm won't work. It will say that it is the wrong answer, even though it is actually the right answer. So I found a way to overcome that problem. We want to force this value of I1 to not be in fraction, and the way you do it is you need to multiply the entire thing, multiply it with 1 point, 1 dot, okay? And when you do that, let's simulate that. You will see that your I1 is now in terms of a number with a decimal point, okay? So let's do that for the rest. We're going to do it for I1, I2, I3, because that's, I2, that's depending on R2, So I'm just copy pasting and then just changing the variables. Okay, and the final one we need to calculate is the total resistance. Now remember that the total resistance, the first thing you need to do is you need to divide between all the different resistors, 1 over R2 plus 1 over R3. So that's my temp. And then I'm going to again multiply this with 1 point. And then my R thought, which is the answer that I want to get from the student, is just going to be 1 over temp. Okay, so let's see whether this works. So I'm pretty okay with I2, I3. I just want to make sure that R thought will give me the answer that I want. Okay, so it's going to be again in decimal with a decimal point. So we're done. So that's it. Then you have actually set up your algorithm. So the algorithm will not only randomize the parameters, it will also calculate the values for the variables which represent the correct answer that the students need to enter. Okay, so you need to make sure that the algorithm is saved. When the algorithm is saved, you will see a message here saying that all changes have been changed, and it will also give you a revision number. In this case, the revision number is 119. Now you need to make sure that the revision number that appears in this window where you edit your algorithm is also the same as the revision number that appears on this window, because otherwise it means that the changes have not been saved yet. So in this case they match, so I can just close this window. Alright, so all changes have been saved, and you'll see that now the algorithm which appeared in the editor before this now appears here. I'm happy with it, so I can just say okay. Alright, so once that's done, click on decode and verify the question text. Okay, this will just do a checking to make sure that you've got all your embedded answers already set up, and you have an algorithm. It says here that the variables depend on an algorithm. You can save the changes and preview. Now when you preview, since you've already got the algorithm which defines the values, you'll find that it no longer comes out as the variable name. Now it actually puts in the different random values depending on how you set it up in your algorithm. If you scroll down a bit more, it will say that, okay, in this case, remember that I had 3 questions with 1 point and 1 question with 2 points, so the total marks will be 5. It also has this thing called question variant. Now this question variant, it gives you up to 100 possible variants for the question that you have. So this is variant number 93, and if you click on the different variants, you'll find that the values will change. So this is variant 1, so the values are different here, and so on and so forth. So if you set this up, it will give you 100 variants. So the possibility of 2 students getting the same question would be quite small. Alright, now the last thing to do is we want to check whether we've got the embedded answers set up correctly. If you click the fill in correct responses button here, what happens is it will fill up the text fields with the correct answer. You can also check the correct answer here under After question summary, there's also a right answer summary where it actually gives you what the right answers are for the different parts of the question. You can also test what happens, you can preview what happens if the student puts in the wrong answer. So let's say the student puts 1 as I1, which is clearly a wrong answer. So you just click submit and finish. And this is what the student will get when the quiz is graded and they get back their graded quiz. So the first question will be incorrect, the answer is incorrect, and if the student hovers around that text field, it will also give the correct answer for the student to compare with the answer that they actually submitted. And that's it for the preview, so we can just close the preview and then finally make sure you save the changes, and then that's it. That's the first question. So even though it's just one question, this will generate 100 variant of the same question because of the randomization of the different parameters.